And I'm live. Hello. So this is to be a short video about Git. Why it's useful, how to use it, and just getting good. Oh, yeah, so Git. I'm gonna use the slideshow as a tool to keep myself on track. If you have any questions, fire away and ask. So, Git. This is what I'm gonna go through. Overview of where we came from, why it's used, a little bit about naming of the main branch, the different online repositories, basic commands, SSH, and miscellaneous stuff. So, Git is a version control system. Its job is to keep track of the work you do, mostly in text files, but it can handle other files as well. It tracks who saved what and when they did it. So you can have multiple people working on the same project at once. Sorry, reading another chat. So, anyone who did the HTML project with me last semester knows how good it can be to all work on the same thing and just merge it all together. So, Git was developed because of Linux, the operating system. When you have hundreds of thousands of people working on one single project, you have to have a way to organize it. They were using another version control system before that. However, it had licensing issues, so they decided to make their own. And there was another version control system at the time that they were not using called SVN. And the brief was to do everything, do the opposite of what SVN does. It has to be performant with large patches. A patch is any segment of code that you add. So adding a lot of code at once had to be performant. It had to be open source because of the licensing issues that they had with their previous version. And one of the key things about Git is each local copy of the project is its own self-contained version. So it can function as a server and local copy. So it's distributed. So previous versions before that had a server that you uploaded all your code to and you got your code from. Git kind of does away with that. Now, because of how popular Git became, it's now used virtually everywhere in programming. And I'd like to show you in a little while how I organized my semester 1 files and folders with it. And so, but the main use now is you commit your code to save it. It gets tested, which means does it run within certain specifications. Like if you have a function that is n plus 1, does it actually do n+1? So you can actually test that programmatically, and you can build your software. So I have a project where I output a website that is all automated. So I just commit and I push it up, and talk about push in a while. I have another one that has a command line tool, and again I just commit it and I push it, and it automatically creates the binaries, which is quite important, because otherwise people could say, but I don't know what's in that file, how can I trust it? And part of the trust with using it now comes from the fact that it's burnt off the code in the repository. So if anyone else burns the code, it should give the exact same file, no changes. It's got a large open source community. Basically, if you go on Gitlab or Github or Bitbucket even, you will find that there's an enormous amount of open source software that people have done. Some great, some terrible, some minor. And it integrates quite well with most modern IDEs. I talked a few days ago about IntelliJ. It links in seamlessly to that. It also links in seamlessly to VS Code. Well, as far as I know, I haven't tried VS Code in ages, so take that with a slight grain of salt. So, a few years ago there was a slight bit of controversy about the naming of the main branch. I'll talk about branch later, but originally it was master, because there was master and slave terminology, in that the master is the source of authority, and the slave was the one that you got orders from the master. It dates back to owner server terminology, but the community at last decided, no, we don't really want to use that terminology, so now it's main. And I think this is a more descriptive branch name. I'll talk about that again in a little while, but that's a slight little detail. So, GitHub, Gitlab, Bitbucket. These are online repositories. You don't have to actually use them. They use Git and then they expand upon it. So they are basically online services that you can push your code to and you can view it publicly. It's extremely useful to share. And the main reason why I'm talking about this is I have seen people make the mistake before of confusing GitHub with Git. GitHub uses Git, but it is not Git. And personally I prefer GitLab. There's a few reasons for that, but that's mostly historic for me. I find that GitLab drives innovation in GitHub. So I'm going to be giving a link to this presentation in the description for the video, but here are the links to download Git itself, and then here's an interactive tutorial that you may want to try afterwards. It's not perfect, but it should give you a good enough practice. And part of what I'm trying to get you to use is the command line stuff. So command line sounds a bit scary at times, but it is incredibly useful to get used to. You can have a graphical interface which helps a fuck ton. There's no way around it. But understanding roughly how the command line stuff works has huge benefits. So, basic commands. Git init is to initiate a new repository. Git status is to view the status of the files in that repository. Git add is to add a file to the stage. And the stage is kind of like a platform above the audience, if you will, if you take the analogy. And the next part is you commit the files on the stage to the repository. So the committing is the actual saving part, and you add a message to it. I'll be giving an example of this in a few minutes, a practical example. The next part of it, that's the very basic part. And these are the very, very basic things that you will do in every repository. The next part is branches. So, have you ever create a code and you feck it up? But you know about 15 minutes ago the code was working. But you cannot remember, you are beyond the limits of Control and Z undo, so you have to manually recode your code as it was back then. Well, that's what branching solves. When you create a branch, it's independent of the other branches, so any changes you make on a particular branch are applied to other branches. So you can have your main, which is basically what works, and you can then create a new branch for, say, lab 9, and you do your stuff for lab 9 there, you make sure it works, you commit it, and then you can, at the end, you can merge it back into the main branch. I'm not going to do the command line stuff for that because I do not like merging in command line. I use the GUI for that. It's just more intuitive for me in that regard. But checkout is how you switch branches. So you literally checking out the other branch. If it's a new branch, you do have to add the -b, which basically says create a new branch with the name new branch. Remotes are where Gitlab and Hub comes into play. These are the same project, just stored on a different server. So you add the remote by using git remote add the name of the remote, which most often is called origin, and then the link to the remote. This particular format here, git@gitlab.com, semicolon repo name git, that is the SSH version. There is HTML versions as well, but this is the way that works quite good long term. I'll be talking about SSH later on. So once you have added the remote, you can then pull in the changes from it, and you can push the changes to it. And again, I'll be giving an example of this in a few minutes. SSH is too detailed for me to go into in depth, but it essentially is authorization. It replaces a username and password for logging into the remote. So you can just push the code without needing to log in with the username and password. A bit more complicated than that, but those documentations should get you started, and I highly recommend using it. There's a few other things that I'm going to cover, but the integration with IDEs, which is for me IntelliJ, large file system, which covers anything that's not a text file, which would be, in the example I give, the PowerPoint files themselves. Because Git works on comparing the changes between the different file versions, it does not work well with Microsoft stuff, so you have to use just saving them in bulk. CI/CD is continuous integration, continuous development, deployment, and it's the testing and building that I mentioned earlier. It's not perfect, but I'm gonna give a better example. And of course, get good. It's not like Dark Souls where it's impossible, but knowing the basics of the command line will help you immensely. And as far as I know, next semester we will be doing some Linux stuff. I'm going to be doing a video about WSL, Windows Subsystem for Linux, in a few days, which should give you an introduction to command line stuff in more depth. So, time for example stuff. So, I said I was going to make this PowerPoint available, and true to its name, I'm going to make it available in a Git repository. So, close that out. I've already created one here, and it's got a nice readme file in there, and this is the folder that I'm going to create the repository in. So I'm not going to open a PowerShell shell here, which is command line for Windows, and I'm going to do git init, which creates a Git repository. You can see here it creates a .git folder. This folder has a pile of subfolders in it. It basically is to keep track of what happens in the repository. You don't normally need to think about it too much, but it's there. I'm going to slightly move this over, and because I have the PowerPoints, which I mentioned, they are not normally good for saving a Git. There's a way around it, which is the large file system. So I'm just going to paste this command in, pptx, and so it's basically Git large file system is going to track this here, which is the star, means all files that end in .pptx, and that it's oh wait, I did that. There we go. And that's going to create its own file named git attributes. And if I just open it up here, just to show you, it's simply a small text file that says what to do with it. So, if I do git stash now, it's gonna say no initial commit. Oh wait, git stash. So I'm on the main branch, no commits yet. These files are untracked, which may not show up perfectly because of dark red and blue, which is not nice. So what I want to do is I want to track git add. add git I'm lazy, git attributes. And if I look at the git status now, we're going to see that changes to be committed is git attributes. These, I'm not concerned about them yet. So I'm going to commit this now with git commit sm, and I want to have it in setting up for this repo. Repo is used as a short for repository, in case you're wondering. And so again, if you have any questions, pop them in the chat. It's what it's there for at the current time. So you can see one find changed, one insertion, git attributes has been added. So if I go git status again, you can see git attributes is not on the list anymore. There are no changes to it. So what if I want to add both pptx's at the same time? Well, git add all.pptx, and if I go git status again, you will find that both of the files, because they match the wiring card of star.pptx, have been staged. So it's git commit -sm, S is signed, M is message. That's what that means there. SM of present. Okay, and so all the files been committed. Now if you recall, the next part of the presentation that I had was remotes. So if I go down to, where is it again? No, not branches, remotes. So remotes are the remote repositories. So I've already set up one on Gitlab, which is, yep. So Gitlab, it has a file in it because it gives you the option when you create the repository. So I'm going to clone, and I'm going to use the Git, the SSH version. You can clone with HTTPS, which, if you know, is normal web requests. And I'm gonna do, where is it here? Git remote add. Normally folks will use origin as the remote name. However, because I have my own personal Gitlab server here right beside me, I am going to use public for the public ones, as you add public. So git remote -v tells you what remotes you have. So in this case it's just one, which is the one I just listed. And before you commit, you must always pull down the new changes from the remote. Git pull origin, no, public. Git pull public main. So I'm going to pull the new commits from the public public remote on the main branch. And you can see it's going to have a little bit of text. So there's a new branch, which is the main. For feck's sake. Let's see. For feck's sake. Why did you have to create... That's one. Sorry, this is slightly unexpected. Ooh. Yeah, I forgot I had it opened. Yes, here. Why are you being stubborn? The joys. One second, I'm just gonna replace this quietly. Presentations. General. So when in doubt, burn and remake. Delete. Not kind of what I intended to have on this. Yeah, it's this part here that fucked me up. Initialize repository readme. It's automatically ticked. Git push. So this should work perfectly. Public. Git push public main. And yep. And if I refresh here, boom, files uploaded. And so I've saved these for public use. And I'm just going to link it here, as well as in the description in a little while. And that is a rough overview of Git. To show an example of it being used not for a non-code purpose, anyone who's in class with me should recognize these module names. I saved everything from university this year in Git repositories, so one repository per module. So for example, what would be a good one? The Java one would be a good, interesting. So you can see I have, well, maybe not the Java one. Maths one? Yeah, maths. So lecture. So general folder. I have the lectures on the PDFs of those, saved, archived properly, and the same with didn't mean to click that. As you can probably guess, this is largely unscripted. The test results, the miscellaneous stuff. And what's more is you can also see what I committed when. So I started it at the beginning of semester 1. I added the first few slides, and I added them periodically over the semester. 141 is probably a bit more interesting. You can see 79 times I saved to it, committed, and you can see the things I changed over time. So the message part is what gives you this part here, and then the name is the person who committed to the repository at that time, and it saves the date. So who did what and when. And that's probably a side thing. But has anyone any questions? I know there's about 3-4 people here. No questions, anyone? So I take that as a final bit, and so did I cover anything? Oh yes, one final thing is tools, Git. So when you open up a PowerPoint, for example, one thing that Microsoft does is create a lock file. So if I go git status, you're gonna see wavy line and $sign with the name of the PowerPoint after it. That's a lock file, and weirdly enough it's not showing up here. I wonder why. Dev tutorials, no, not showing up there. But we don't want to add that file to the repository, so there's a nice little handy file called gitignore. Rename gitignore. Gitignore. Windows does not like creating files with only a extension, so you kind of have to copy an existing one. And the way gitignore works is quite simple. And you can use the wildcards like that. So I'm gonna do the wavy symbol, $sign, and then 2 of these. So the first one says any file name with a wavy $sign at the front, and then the dot is the extension, and then any extension, so that can be PowerPoint, docx, whatever. And then if I come back here to go get status, oh, why are you showing up there? You're not supposed to show up. I have it saved properly in one of these. So, oh, just that. Never mind. Far simpler than I thought. Any extension. Git status. So the wavy one disappeared, and it's now just gitignore. So git add git ignore lock files. And I just want to push that up, git push to the main branch of the public repository, public remote. And see, it does a little bit of boilerplate text there, and I can go and refresh, and boom, the git ignore is there. So I'm gonna wrap it up here for the moment, and possibly see you later, another day. Have a good evening.